Hi everyone, for today's lesson we are going to be learning about classifying polynomials, direct and synthetic substitution, and later on in another video we are going to talk about end behavior. Our learning objectives for today is for you to be able to say, I can determine if a function is a polynomial function, I can identify the degree, the type, and type of the polynomial function, I can evaluate the polynomial function using both direct substitution as well as synthetic substitution. And I can describe the end behavior of a polynomial function. Now, recall, we've talked about monomials before, and remember that a polynomial is simply a monomial itself or the sum of monomials. And monomials is where you might have variables, you might have numbers, or you might have a combination of variables and numbers with different types of exponents. Now, a polynomial function is f of x equals some sort of leading coefficient times x to an nth power, then another coefficient times x to the n minus 1 power, and then n minus 2 power, and so on, where our exponents are decreasing in value. So it might be an x cubed, an x squared, an x, and then nothing, where a sub 0 would represent the constant. So we have n would represent the exponents. So I have n and then n minus 1 and so on. These exponents must be whole numbers. So that is something that is very important in terms of the definition of a polynomial function. Exponents must be whole numbers. And the coefficients have to be all real numbers. So they have to fall into the category of all real numbers. So you are not allowed to have an imaginary unit as a coefficient. And they can be any number. They can be, the number pi. It can be a radical. It can be a decimal. It can be the number 2. All of those are considered reasonable coefficients. A sub n represents the leading coefficient. So the number that is in front of the highest exponent, the variable with the highest exponent. This is called the leading coefficient for this polynomial, where n is considered the degree of the polynomial. So n being the largest coefficient, the largest exponent. The largest exponent is going to represent the degree of that polynomial. A sub 0, which is what we are adding at the very end, whatever that value that has no variable next to it, that is considered the constant. A sub 0 is the constant of the function. So it's the number that has no variable next to it. Now, a polynomial is written in standard form if the terms are written in descending order of the exponents from left to right. So what that looks like is you would have something like y is equal to 4x squared plus 3x minus 1. The exponents would be 2, 1, and 0. So they're in descending order. And where 0 comes from is anything to the 0 power is the number 1. So this constant term always does have a variable next to it. It's just you can't see it because that variable is raised to the 0 power, and 0 power means that that variable is the number 1. So just putting that out there. Putting it all together in terms of the degree and type, we have a constant function. A constant function is simply f of x equals a number. So if you see that f of x is simply equal to any number out there, that function is called a constant function, and its degree is 0 for the same reason that I just said before. technically these values do have variables in front of them, or after them. It's just that variables raised to the 0 power. And anything to the 0 power is equal to 1. So therefore, this is really just like negative 14 times 1, which is negative 14. And we never, ever, ever write it as x to the 0 power. We always change that to a 1 really like immediately. Or we simply just don't write it. So anyways, if you see it like f of x is equal to a number, that's called a constant function with the degree being 0. The next function is a linear function. Those are the ones that are in the mx plus b format. And that degree is 1, and that's because technically there exists an invisible number 1 as the exponent of our variable. So like f of x is equal to 5x minus 7, there is an invisible number 1 next to the x. And so that is considered a linear function with a degree of 1. Our next one is called quadratic. That has a degree of 2. And so what you're going to see is that the largest exponent will be the number 2. And if that's the case, we call those quadratic functions. Now, when you're in Algebra 1, we primarily focus on those that are degrees 0, 1, and 2. And so now in Algebra 2 with trig, we are going to be talking about other types of functions. The next one being cubic. Think of cubes. Whenever we have volume of a figure, that's length times width times height. We always have units cubed, so it's cubic. So to the 3rd power, or degree being 3, cubic, you're going to see that the highest exponent, the largest exponent, is going to be the number 3. And look at the descending order, or the standard form, 3, 2, 1 in terms of our exponents. Next we have quartic. Please be careful. Quartic and quadratic are completely different. I need you to know what a quadratic is versus a quartic. There are 4 quarts in a gallon, so that's one way to remember quartic. 4 quarters in a dollar, quartic. So just be careful. Quad, a lot of people have it in their head that that means 4 as well, but we have already worked with quadratic, so I'm hopeful that you recognize that quadratic is when the degree is 2, and quartic is when the degree is 4. So our largest exponent here is going to be the number 4. You might see a degree of 5, and that is called quintic. But otherwise, any other function that is so if you see the degree being, highest degree being 5, that's called quintic. After that, we call it 6th degree, 7th degree, etc. Sometimes we work with quintic. I just wanted to make sure that I put that out there. You might see that in a problem or two on your homework. So let's look at example number 1. We had a lot of information here on definitions of terms, and what we want to do is we want to complete the table and decide whether each function is a polynomial function. And if so, we want to identify the leading coefficient, degree, and type. So we want to decide whether each function actually is a polynomial function, and if the answer is yes, then we would identify further. So looking at our first example, we have y is equal to n to the negative 2nd power minus 3. Is this a polynomial function? Well, let's go ahead and look up here. Our exponents must be whole numbers. Now, whole numbers are 0, 1, 2, 3, 4, etc. They are whole numbers. They're not allowed to be negative. So in this problem, y equals n to the negative 2nd power minus 3, the answer is no, this is not a polynomial function. And the reason for why we're going to say that is because it is the exponent is negative, or the exponent is not a whole number. So because the exponent is not a whole number, this is not a polynomial function. Let's look at the next one. We have f of x is equal to x squared plus 5. My exponent is the number 2, and that's a whole number. I don't see any other problems. My coefficients are real numbers, so the answer is going to be yes. And the reason why I'm going to say that is because the exponents are whole numbers and the coefficients are real numbers. All right, let's go ahead and look at our degree. The highest exponent that I see here is the number 2, so that is my degree. My type, because the degree is 2, is quadratic. And my leading coefficient, well, that's the number that's in front of x squared, and that's an invisible number 1. So my leading coefficient is the number 1. Let's look at the next one. I have x to the 4th power plus x minus 3. So once again, I have all coefficients are real numbers, and all of my exponents are whole numbers. So the answer is yes for the same reason. The exponents are whole numbers, and the coefficients are real. So therefore, my degree is the highest exponent, which is the number 4, and we're going to call that quartic, with our leading coefficient once again being the number 1. Next, we have y equals 4 to the x power. Now, x could be 0, 1, 2, 3, or 4. But we also know that x could be any number. It could be negative. It could be a decimal. It could be anything. So therefore, the answer is no. And that's because x is an exponent and could be any number. And because it could be any number, that means it could be something that's not whole. And so therefore, y equals 4 to the x power is not a polynomial function. Instead, it's an exponential function that we will study later on in this course. Next, we have y is equal to 9. And in this problem, the answer is yes. This is a constant function, and that's because technically, x is being raised to the 0 power. So the answer is yes, and that's because the exponent is a whole number, and the coefficient, which the coefficient in this case is 9, is a real number. So in this case, my degree is going to be 0, and this is called a constant function. Constant functions are always poised. They're always graphed as horizontal lines. In this case, my coefficient is going to be 9. For the next one, we have y is equal to n divided by 2. Technically, this is really y is equal to 1/2 n. So this is actually a linear function. The answer is yes. This is a polynomial because technically n is being raised to the 1st power. So once again, I'm just going to put quotes because I already had a yes from before. Yes, because the exponent is a whole number and the coefficient is real. This one has a degree of 1, and it is a linear function with the leading coefficient being 1/2. And that's because that's the number that's in front of the variable. Next, we have f of x is equal to 3x to the 3rd power plus 4x to the 2.5 power minus 6x squared. And in this case, the answer is no. So yeah, although I do have exponents that are whole numbers, this 2.5 ruins everything, and 2.5 is not a whole number. And because it is not a whole number, it therefore ruins this whole equation and makes it not a polynomial. Next, we have y is equal to 7x minus the square root of 3 plus pi x cubed. Now, although this equation is very ugly, it's not written in standard form in any way, shape, or form, it is, yes, considered a polynomial function, and that's because the exponents of my variables are 1 and 3. And all of the other numbers, 7, square root of 3, and pi, they're real numbers. So the exponents are whole numbers, and the coefficients are real. There's nothing imaginary about any of those values. And so now looking at the largest degree, my largest degree is the number 3. So this is a degree of 3, and we're going to call that cubic. The value that's in front of the x cubed term is pi, and so that makes pi the leading coefficient. So it's all about what is the number that's in front of our variable. Next, we have h of x is equal to 3 divided by x plus 4 times x to the 4th power minus 7x. And in this case, the answer is no. Now, although it's 3 divided by x to the 1st power, technically, if you go back to what you learned in Algebra 1, 3 over x really means 3 times x to the negative 1st power. If we were to bring that x up so that it's in line with 3, technically our exponent is negative. So in this case, negative 1 is not a whole number. And because it is not a whole number, no, this is not a polynomial function. All right, let's go ahead and move on to the next page. And what we're going to learn is this thing called direct substitution. And direct substitution is something that you have learned and used in this class a lot so far. So what I'm about to show you, I'm just giving it a name called direct substitution. So using direct substitution, we're going to evaluate this polynomial function for the given value of x. So to evaluate or to substitute means that we're literally going to replace x with the value that's given to us. So I have f of x is equal to 2x to the 4th power minus 5x cubed minus 4x plus 8. So direct substitution is f of 3 is equal to 2 times 3 to the 4th power minus 5 times 3 to the 3rd power minus 4 times 3 plus 8. And to use direct substitution, you're going to be using your calculator and directly substituting it in exactly as you see it, making sure you use parentheses and all. I'm going to do this a little bit slower instead of just using my calculator because I really want to emphasize the fact that you have to take care of exponents first before you do anything. So this is really f of 3 is equal to 2 times 3 to the 4th power is 81, minus 5 times 3 to the 3rd power is 27, minus 4 times 3, which is 12, plus 8. And I'm going to put that into my calculator because I think it's a lot easier to do that. So when I put 2 times 81 minus 5 times 27 minus 12 plus 8 into my calculator, I'm going to end up with 23 as my answer. And that's it, direct substitution. Let's go at the solo question. We will talk about that the next time I see you in class. Let's go ahead and look at synthetic substitution. So in synthetic substitution, you need to make sure that every degree is represented before you use synthetic substitution. So if you think about the word synthetic oil in your car it acts like oil, it gets the job done like oil, but it's not just regular car oil. It's synthetic. It's something that does the job but is not necessarily real. Like we might work with synthetic fabrics and have clothes that have synthetic fabrics. Synthetic is like fake or a replacement for something that is real but gets the job done. So what I'm about to show you is the foundation for a skill that we are going to be working with a lot later on in this unit. And if synthetic substitution was the end-all be-all of the way that we are supposed to be evaluating functions, you would learn it back when you were in 6th and 7th grade when you started substituting then. But now that you are in Algebra 2 with trig, you are now ready to see this new way of substituting and evaluating a problem. So let's go ahead and look at example number 3. What I'm about to show you is a little weird. I need you to write down everything that I show you, follow along. It is a process that will be used again later on in this unit that I need you to know how to use now. So here we go. Synthetic substitution. The first thing I'm going to do is I'm going to put -2 inside of a box. And I'm going to write down, making sure that every degree is represented. 3, 2, 1, 0. Every degree is represented. I'm going to write down just the coefficients of these values. So the first coefficient is -3. Leave a little bit of space. You're not going to want to write the next coefficient right next to it to make it look like a 31. Leave some space. 1. Leave some space. -12. Leave some space. -5. Now, between our last two values, we're going to draw a vertical line and a horizontal line, leaving this little extra box on the side. So now that I have my -2 that goes inside of my little box, and I have all of my values on the outside, the first thing I'm going to do is bring down my very first term, which is -3. We always add in the add above the line, and then we multiply below the line. So it's addition above and multiplication below. -2 times -3, that answer is 6, and that goes into the next line. 1 plus 6 is 7. Now we repeat. -2 times 7 is -14, and that's what goes right here. And now I add -12 minus 14 is -26. -2 times -6 is +52. And now I add, going straight down, -5 plus 52 is equal to 47. And there is my answer. Let's go ahead and verify. If you were to put into your calculator, f of -2 is equal to -3 times -2 to the third power plus -2 squared minus 12 times -2 minus 5. Go ahead and put that directly into your calculator and see what you get. If it helps, simplify this. F of -2 equals -3 times -2 to the third power, which is -8, plus -2 squared, which is 4. -12 times -2 is plus 24, and then minus 5. Put that directly into your calculator and see what you end up getting. Do you get 47? I gave you some time to put it in your calculator. You get 47. So this process called synthetic substitution, where I wrote down whatever number I was going to be substituting, went into the little box, and I wrote down all of my coefficients, and I left some space so it didn't look like a big old weirdo number. We have -3, 1, -12, -5. I drew a line, a vertical line in between my last two coefficients and a horizontal line with some space. I added above and multiplied below, bringing down my very first number first. And I multiplied -2 times -3, and my result went up here to 6. 1 plus 6 was 7. -2 times 7 is -14. Negative 12 plus negative 14 is negative 26. Negative 2 times negative 26 was positive 52, and negative 5 plus 52 is 47. It got the same exact result as direct substitution. And like I said to you before, direct substitution is the most preferred method for substitution. If it wasn't, then you'd be learning synthetic from the time that you were little or in middle school or whenever you started learning about substitution. But I need you to now, mathematics needs you to now, in our math world, we need you to now be exposed to this new method because we are going to be using it later on in this unit. I would like you to please go ahead and try the pair on your own, and that is the end of the first part of our very first lesson. The next part is something that I would like to do an exploration before we get going into it. That is the end of today's part. If you have any questions over anything, please feel free to email me. Otherwise, I hope you have a wonderful day.